In this section, we'll learn how to do a confidence interval for a proportion. So we have a one sample z confidence interval for a population proportion. Now, you might remember the general form for a confidence interval is our estimate plus or minus a critical value times the standard deviation of the estimate. And we said for a large sample size, when we talked about the sampling distribution, we said p hat has an approximately normal distribution with the mean of p hat equal to p and the standard deviation p hat equal to the square root of p times 1 minus p over n. So we could find a z confidence interval. Notice we do our estimate. Our estimate of p is p hat. Critical value we just call z star because it's a normal distribution, so we can use z. And the standard deviation would be the square root of p times 1 minus p over n. But we can't have p in a formula to find p. Okay, so we can't estimate our population proportion with a formula that uses the population proportion. So what would we do instead? Any ideas? So we would estimate p with our sample proportion of p hat. So let's choose a simple random sample of size n from a large population. We have an unknown proportion p of successes. Our sample proportion is p hat equals x over n, just to remind ourselves. And then our standard error of p hat, this is our estimate of the standard deviation of p hat. We call it the standard error. Will be p hat times 1 minus p hat over n. So instead of using the actual standard deviation, we'll use the standard error. That gives us an approximate confidence interval for our population proportion. So we'll have p hat plus or minus z star times the square root of p hat 1 minus p hat over n. Now the conditions for this is our sample size has to be large enough to have n times p hat at least 10 and n times 1 minus p hat at least 10. This is actually the same thing as checking the number of successes is at least 10 and the number of failures is at least 10. Just depending on what I give you, one might be easier to check than the other. Also, with proportions, we also assume our population is much larger than our sample, usually like 20 times as large. Otherwise, you start to have problems with the observations not being independent from each other. Now, in practice, your population is almost always going to be much larger than your sample, and so this isn't something we actually really worry about checking, and we certainly won't check it in this class. To use our calculator, we'll be looking for a confidence interval in there somehow that says like a z for proportions or like a 1p z and then 1p for proportions. But both the TI and Casio require you to enter x, which is the number of successes, instead of the actual sample proportion. Some software makes you use sample proportions, some software makes you do the number of successes. Also, anytime we use the normal distribution with proportions, it's possible to use what we call a continuity correction to be slightly more accurate. We're not going to do that in this class. Some software will do it automatically. And if your software does, it's not a bad thing. It'll just be slightly more accurate. Let's try it then. A company who makes cheese spread is considering a new spout design. They won't use the new design if more than 5% of the people will stop buying it. So they took a sample of n equals 1,000. Okay, and 63 said they stopped buying it. So x is going to be 63. We want to find a 99% confidence interval for the true population proportion of people that stop buying it. We can also find p hat, which would be the 63 out of 1,000. So 0.063. So it looks like about 6% in our sample would stop buying it. We want to figure out what it would be in the entire population. I do need to check the conditions. So we need to check either n times p hat or our number of successes. Okay. So our successes, okay, are 63. That's at least 10, so check. And the number of failures then, or 1,000 minus 63, would be some really big number, and that's going to be bigger than 10 as well. I don't even need to put that in my calculator to know that it's going to be bigger than 10. Or, if you want, you could do n times p hat. So that's 1,000 times 0.063. But guess what? That's just going to put you right back to 63. And that's at least 10. So we're good. or n times 1 minus p hat, is 1000 times 1 minus 0.063, which is going to give me 937, and that's at least 10. So we're good there too. So you can see how either checking n times p or checking the number of successes and failures, either way is telling you the exact same thing. To find our confidence interval, I'm just going to use my calculator. I'm going to go to stats and order the test because that's where TI put the intervals. And look for something that sounds like proportions, z, interval. Oh, so there we are. So one sample, proportion, z, interval. You put in x is 63, n is 1000, confidence level is 0.99, and we get 0.043 to 0.083. And then we can interpret the confidence interval as it's a we are 99% confident that the proportion of all of our customers who would stop buying is between 0.043 and 0.083. Now, most people like percentages better, so you could say 4.3% to 8.3%. Now, if you remember, the company was not wanting to switch if more than 5% would stop buying. So 5% is in that interval of 4.3% to 8.3%. So it might be less than 5%, but it is likely about 5% or more. So they might not want to switch. Now for another example here, Shawnee took a sample of 30 random people at USU and asked how many live on campus. In our sample, 30% said they live on campus. Find a 90% confidence interval for the true proportion of all students at USU that live on campus. Okay, so first check your conditions. So, well, let's write down what they tell us very first. So n equals 30 and x equals 3. Okay. So we can do this two ways. We can say our number of successes is 3. That is not greater than 10. So this is too small. Okay, we can't do this test. We would have to do a non-parametric test or confidence interval. So the sample size is too small. We can't do this confidence interval. Okay. There's another problem for you to try. Okay. And one last thing here is margin of error and polls. Okay. Because this is something that's very common in real life. So the media often expresses the margin of error in a confidence interval for P in percentage points. They don't tell you they're giving you a confidence interval, but that's what they're doing. So for example, suppose a news report says that a recent poll finds 34% of the public favors military intervention in an international crisis. They report the margin of error to be 3 percentage points, or that the sample results will be within 3 percentage points in the population in 19 out of 20 samples. So what does this mean? Well, first of all, 19 out of 20 equals 0.95. So this means they found a 95% confidence interval for the population proportion to be 34% plus or minus 3%. So basically 31% to 37%. They just didn't say it, but that's really what they did, is they found a confidence interval. Now, when they say it should be within 3 percentage points in 19 out of 20 samples, what they're saying is they're just describing what the confidence level means. So they're saying out of all the possible samples, 95% of the resulting confidence intervals would actually contain the population proportion mu, or p. And 19 out of 20 is that 95%.